Massimo, it's good to see you again.
Hello there. How are you?
I'm doing great, and let's welcome the audience to the second episode of Sophia.
Oh,
And
I've heard the name before.
yeah, they asked me for a name, and I figured wouldn't mind something Greek, and so
Sure.
and my Greek's better than my Latin, so
Oh, there you go.
so why don't we introduce ourselves, and then we can get started on our topic for today. Massimo, would you like to go first?
Yes, so I'm Massimo Pigliucci. I'm the KD Irani Professor of Philosophy at the City College of New York.
And I'm Daniel Kaufman. I'm a professor of philosophy at Missouri State University. We are trying out a new recording software, which is why I'm not in my usual place. I feel a little exposed rather than being surrounded by all my books, but it'll work out just fine. So,
Yeah, I still have Descartes and Aristotle on my back, so it's like you're watching my back. So that's
yeah,
I feel good.
I love those. I love those pictures. Okay, so today we agreed that we were going to talk about what's called the strong artificial intelligence thesis,
Right.
and all the implications of it and some of the main criticisms of it and such. And as is always probably wise, maybe we should start with some definitions of concepts. So, how do you understand what's called the strong artificial intelligence thesis?
Well, so the term comes from the heyday of that program, that particular research program, where computer scientists and some philosophers of mind, this was decades ago at this point, thought that true artificial intelligence was going to be around the corner, and by true artificial intelligence, uh, that's where the trouble begins because it's not exactly clear what they meant. Um, you know, what they were talking about intelligent and or conscious computers, and that to me has always been one of the fundamental issues with the strong AI program, because intelligence is not the same thing as consciousness. The two are obviously related. I'm presumably an intelligent person, sort of more or less, and I'm certainly conscious. But you can have a very intelligent machine, like my smartphone is really smart. I mean, it's very intelligent by the standards of doing computations very fast, accessing information very fast, accessing a lot of information, and that sort of stuff. But it's presumably not conscious, even though Siri sometimes does give me weird answers when I talk to her. But nonetheless, so I understand the strong AI thesis as it is possible, and in fact, it will be soon feasible to have a computer that is either as intelligent as a human being or more, or as conscious as a human being. And as I said, that's where the problem starts from the beginning, because I actually would agree that we can have smart computers. I'm not sure that we can have conscious computers.
Okay, so let's work with this a little bit. So, not being a computer scientist and not coming at it from that angle, but coming at it from the philosophy of mind,
Right.
when I think of the strong AI thesis, what I always think of is, and I mean, I teach this. I mean, I teach this material at the university. I think of the research program in the philosophy of mind and in cognitive science, in which the idea was that computers and the ways that computers work was going to explain to us what the human mind is and how the human mind works.
Yes, so that's right. So that's yet another reasonable way of understanding the strong AI program, which is as a model, as a replication essentially of the human mind, which would be used at least in part in order to understand how a human mind works. The idea being that if you're capable of essentially reverse engineering something or simulating something very closely to the original, then you have a better understanding of the original. But I think that thesis got lost very quickly, meaning that the path to that outcome, because it has become immediately clear, even to optimistic supporters of the strong AI approach, that because of issues with materials, because of issues with technical issues with having to provide the computer in question with access to the external world, the ways to navigate the external world. We're not talking about a computer anymore. We're talking at the very least about an embodied computer, so a robot. And that has become, it's very clear that it's actually very, very difficult to do. I mean, it's possible. I mean, I don't think there's anything physically impossible about that, but it's remarkably difficult. I mean, there are a number of issues, a number of tasks that are very easy for a human being to do, which turn out to be very, very difficult to solve from an AI perspective. Just, things like face recognition and solving simple puzzles, simple ways of walking around or orientating oneself around an environment. So again, but you're right. I think that is another good understanding of the strong AI thesis. Yeah.
And I appreciate very much the distinction you want to make, because it doesn't seem, at least on the face, to be quite the same question. On the one hand, can we make a machine that thinks? And on the other hand, is human thinking essentially what a computer does? Is human thinking a computational process? But let me maybe make one suggestion as to why maybe they're not as different as somebody might like to think they are, and that is that the only example of mental states and thinking that we have are our own. And so when we talk about, on the first side of it, can we make a machine that's thinking? What we mean is thinking in the sense that we commonly understand it, which is what people do, right? And so in a sense, then, aren't we in a sense engaged in the same enterprise? And that is whether we think of it in the first way that you described or in the way that I described afterwards, or do you still think we can usefully separate these projects such that even if the second one doesn't work, there might be hope for the first?
I think that there is a conceptual distinction there, but whether that's actually going to turn out to be a distinction one can cash in somehow, I think you're right. It's entirely open to question. Let me draw an analogy there with a very different field with which I'm more familiar as a biologist, and that is the origin of life issue. Right. So when we say that we are looking for life on, say, Mars or Titan or whatever it is that we're going to be looking for life, we clearly mean life as we understand it today on planet Earth, because that's the only model we have. Right, and people have tried to generalize and have tried to say, well, but here are the general characteristics of life, so we think that other things can qualify as being alive, or here's maybe ways in which you can have a life that is not based on carbon like the one on Earth is, but maybe on some different elements such as silicon. But those attempts have immediately run into serious problems. So because if you start defining, first of all, it's notoriously difficult to define what life is.
Right.
Just like it's notoriously difficult to define what consciousness is or what intelligence is. So there's an analogy right there. And often we basically end up saying, well, we know it when we see it, kind of thing, which is not very satisfying, but sometimes that is the best you can do. Moreover, whenever people have started saying, well, okay, so life is something that's characterized by, I don't know, it's a system that is capable of reproducing and evolving, and so this is the Darwinian definition basically of life. Well, yeah, fine, that's all fine and dandy, except that, of course, if you define it that way, we already have computer algorithms that you would have to define as alive. And frankly, I don't go that far. I'm not going to bite that kind of bullet. I don't think computer algorithms are alive. And so if your definition of life implies that computer algorithms are alive just because they can evolve, mutate, and evolve in response to their environment, then I'm going to have to say, I got a problem with your definition of life. I'm not going to accept that computer algorithms are alive. So that's one thing. The other direction in which people have gone classically in terms of sort of exploring the question of life is, okay, let's try to think, this was Carl Sagan famously, for instance, let's try to think about can we conceive of a life form that is not based on carbon? And typically the major viable candidate is silicon, which is an element very close to carbon in the periodic table, right? Is it possible to have a silicon-based life? Sure, it's possible, I suppose. But the problem is chemists immediately started pointing out that actually silicon has a lot less chemical flexibility than carbon. The carbon really is special. Carbon is an element that really can do amazing things in terms of sort of bonding, not too tightly but not too loosely, with a bunch of other things and in a bunch of different combinations, which no other element pretty much on the periodic table can do. Now that doesn't in and of itself show that that life is possible only based on carbon, but it surely puts the burden of proof on the other side, I would think. So similarly, in the case of artificial intelligence, right? I mean, you're right. The only example we have is the human one, or at least humans and closely related primates, let's say, which means these are all biological systems. In all cases, we define intelligence in a very particular way. And these are all systems that are made of certain particular things that work in a certain particular way. Is it possible? Is it conceivable to replicate some of those characteristics of behavior and at some level intelligence by using different systems built in different ways and of different materials? I don't know. I mean, we don't have an example of that.
Right.
It's not a. Sometimes I feel, like supporters of strong AI and a number of philosophers of science, philosophers of mind, just too quickly say, well, there's nothing special about the human mind. Well, how do you know? We don't have other examples of minds out there. So to me, that feels pretty damn special.
Yeah.
And I think that's specialness seriously, I suppose.
It's really very interesting, and I think I can already see where some of our conversation is going to go, because you've already gotten to the issue of whether substrate plays an essential role in this, and then on the other side, some of the reasons why people want to sort of get away from the idea that it's based on substrate, which I think we're going to get to. But I just wanted to say one thing that occurred to me while you're talking about the biology case. I think at one level, the problem here that we're dealing with is a problem inherent to limitations of language, and that is, you really, once you start asking, can we imagine a radically different X? What you mean by radically different is really radically different. You start pushing the boundaries of, well, then would it count as an X, right? Davidson has this famous example where he says, the problem with imagining an untranslatable language is how would you know it was a language to begin with, right? And not just noises, right? And so I think that there is a certain just limitation in terms of the way that we form and use concepts. When you ask the question, well, can you imagine a life form that is so radically different that it even begins to no longer even bear vague family resemblances, right? You start getting beyond. It's not an answerable question, right?
Exactly.
Yeah.
So I think that it is much more productive to keep the discussion to, well, can we imagine something that either is very much like human intelligence or is in that family, to use your terminology, it is in that family resemblance neighborhood. And that neighborhood is in fact fuzzy. There's no sharp boundaries for these kinds of things. But if you start talking about something radically different, then I'm afraid that the discussion is off the table until you can actually operationalize, well, what do you mean by that radically different? Radically different in what sense? And if it is that radically different, as you said, why would it count as a case of intelligence or consciousness or both?
Right. So I think this is a good place now to get into the next topic, which is what do you see as the relationship between this research program, this way of thinking about the mind and about thoughts, the relationship between it and the Turing test? So
gotta talk about the Turing test. You cannot have a conversation about the Turing test.
That's right. Okay, so how do you see the relationship between the Turing test and this research program?
So the Turing test, right, we should remind, I'm sure that most of our viewers will know what the Turing test is. But this is the idea, which goes back to Alan Turing, that, how can you possibly tell if a computer is intelligent or not? And the idea is, well, why don't we do a behavioral test, essentially? Probably not coincidentally, although I'm not sure about the direct connect, if there is any direct connection there. But Turing proposed that test pretty much at the time where behaviorism actually was a thing in psychology, which is, forget about internal mental states, because we don't have access to internal mental states. The psychologists were saying, just look at behaviors. The behaviors it's all the data you can get, and that's all where you should stick. Well, Turing essentially proposed the same thing, and he said, well, look, if we imagine the situation where you are communicating with another entity through a keyboard and a screen, and you keep you keep the communication going for a while, and you cannot tell whether the entity at the other end of the terminal is a human being or a computer, for all effective purposes, you have to admit that the computer is in fact intelligent. Behaviorally, it comes across as intelligent, right? Now, that's fine as far as it goes, except for a couple of somewhat major caveats, I would say. First of all, if we do buy that there is a distinction between intelligence and consciousness, a computer may be able to pass the intelligence test and not necessarily the consciousness test. In fact, it cannot pass the consciousness test because the Turing test is not a test of consciousness, right? It's by definition, it's not about internal mental states. So I can imagine having a computer that is very, very, good at answering my questions, got a knowledge database with a piece of software that allows it to understand, nuances of human language or a particular human language, let's say English, answer the questions properly as if, in fact, there was somebody understanding there, but in fact, with no understanding, with no conscious experience. Now, before I go any further, I'm often accused, when I say something like this, of going for a David Chalmers style, zombie argument. That is, it sounds like what I just said is the same as saying, it is conceivable that an entity with my internal structure, brain structure and everything, and outgoing behavior, somebody who is talking like me and reacting like me, internally actually does not feel anything, does not have internal mental states. That is not at all what I'm saying. Because what I'm saying is, remember, in the case of the Turing test, you don't know what the internal structure of the computer is. In fact, internal structure is normally very, very different. So I'm not making a zombie argument at all, even though sort of superficially it kind of sounds like that. So that's the first problem with the Turing test. That is, it's a test of intelligence at best, however you want to define intelligence, but not a test of consciousness. The other thing is the way it has been implemented, of course, so far, because there is an annual competition actually for computers to pass the Turing test, right? And this past year, actually, at the last edition, somebody claimed that they actually passed it, and it turns out they were a little bit cheating because they presented a character that was, I think it was a boy whose native language was not English, which meant that the computer program was automatically excused essentially from making, when he was making mistakes in answering certain questions. Now that's a little bit of cheating. But regardless, the test as it's implemented, I think lasts only about 5 minutes. So it's a determined period of time. And one can make the argument that we know already that it is possible to mimic a conversation with a human being for much longer than that. And this has been possible for a long time. I don't know if you've ever seen the ELIZA program, computer therapy program. This has been going on for, way before there were personal computers, and you can now download it or play with it on the internet. And it's this computer that simulates a therapist, right? And so you can ask questions to ELIZA, and ELIZA responds in a way that sounds very much like a therapist. Now, I don't think that's a particular compliment to therapists, because it's like,
that's funny.
Say, it's so easy to simulate a therapy session.
That actually was first imagined in a science fiction novel called Gateway by Frederick Pohl.
That's right.
Yeah. The whole thing is backflash of him talking to this machine shrink about what happened to him.
And if you play with ELIZA, you do get this feeling that you're talking for a while, that you're talking to a human being. I mean, after a while, it gets repetitive, and you kind of sort of figure out that you can ask the kind of question that stumps the computer program. But ELIZA's code is incredibly simple, and it's not very adaptive. We can now write code that is much, much more flexible, much more adaptive, that draws on large databases, so that I can easily imagine a good computer programmer that can write a program that can fool most of us for hours, if not more. But does that show that the computer programming question actually understands what's going on? I don't think so. I think that the Turing test is hopeless in that sense, precisely because what it's supposed to be its strength, which is ignoring the internal mental states of the machine, is actually the crucial weakness. Well, without the access to the internal mental states, without the equivalent of a sort of an fMRI machine that looks at what's going on inside the computer, you can't tell the real thing from a simulation.
All right, so let me defend the Turing test a little bit and see what you think. I could see two reasons why something like the Turing test might be appealing from the standpoint, even today. I mean, I think you could make a case, and I would say the following. First, it's a way of getting around the problem of other minds. In other words, there is a classic skeptical problem in philosophy, which is, how do you know other people are thinking? And let's not even try to disambiguate intelligence from consciousness. Let's just talk ordinary language. Right. Is that individual over there thinking? Okay,
right.
Or
is he a zombie? Because the equivalent, the other possibility would be zombie, right?
So the fact of the matter is that the basis on which we infer other people are thinking is on the basis of their observable behavior. And if you ask, well, how else would you know? It's hard to see what an answer would be. Now, some people have tried to say, well, you can justify the inference that the other person is thinking beyond the behavioral evidence on the basis of analogy, because we know that we're thinking, and therefore. But arguments from analogy are notoriously problematic and difficult to ultimately justify. So on one hand, I could see the Turing test is a way of sort of changing the standard such that you avoid the other mind's problem, right? That the way we decide whether this machine thinks is the same way we decide whether the guy sitting next to you is thinking. We look at how they act. Right. Along those lines, also, Wittgenstein who is very suspicious of internal explanations of external behavior, said there would be something very perverse if we saw someone writhing on the floor to ask whether they're really in pain or whether they're just. In other words. Right. This is just not the way we ascribe on a normal basis. We really do ascribe roughly along the lines of Turing tests, of little mini Turing tests in the sense that go on all the time. So that would be one plug I would make for it. The other plug I would make for it would be, it also gets around the question of substrate. In other words, sure. Precisely what we were talking about before. Could radically different kinds of things think? Right. And where we're pushing the boundaries of imagination, well, we have this very deep-seated intuition that at least there's no reason why they shouldn't be able to, right? And so isn't a way to avoid all of this to get away from questions of substrate and what things are made out of, and talk instead about how they perform.
Yeah. So no, you're absolutely right, but let me push back a little bit.
Yeah, please.
On the first count especially, you're absolutely right, of course, that if we're talking about sort of everyday experience, yes, that is how we tell not only if the person next to us is thinking, by the way he's talking and all that, but if you answer the phone, for instance. We run a Turing test every time we answer the phone. Yeah. Because how do you know that there is a thinking person on the other side? Well, you start talking to them, and pretty much you'll figure out if it is a recording or not, right? So that's true in terms of sort of everyday experience. But if we're talking about a science of artificial intelligence, that's where I'm going to invoke my background as a biologist and say, well, yes, but a biologist got a better argument for why do I think that other people think, as opposed to just behaving as if. And the argument comes from the coupling of the behavioral component. The behavioral component has to be there. I mean, without that, we're dead in the water. But that one, with all the information we have now about how we think, what makes it possible for us to think. So you open somebody's skull and there's a brain, and if you start poking on that brain in certain ways, certain things happen, including the impairment of language, for instance, or the impairment of certain cognitive functions, and so on and so on. You can experiment with this kind of stuff. You can also describe it functionally to some extent without opening it up, right? So the functional MRI studies, for all the hype that often accompanies them, but still, they do show you, at least indirectly, that certain areas of the brain seem to be functionally correlated to certain human behaviors or certain ways of reacting. It would be really surprising, let's say, if we were talking, I was talking to somebody, and then I opened up his skull, and it was empty. There was nothing inside. Right? Now, then I would start thinking, whoa, wait a minute. There's got to be some ruse here. There's got to be some issue. Or maybe I am, in fact, witnessing a situation in which somebody can do what a human being can do, but by completely different means, by radically different means. So I do think that there is a sense in which we want more than just the behavior. If we're talking not about a day to, an everyday encounter with somebody, but we're talking about a sort of a scientific approach to something. But you're right on the second point. That brings us to the problem of substrate. And is the substrate crucial or not? We don't know, and it really is going to be very, very difficult to find out, because we can find out all sorts of interesting things about the limits of our own substrate, right? As I said, you can take parts of the brain out, of actual human brains out, or you can interfere with them. You can do all sorts of interesting experiments and show that certain things seem to be certain areas of the brain and certain connections within the brain seem to be crucial for certain cognitive tasks. What we cannot do is to replace those parts with sort of artificial parts, let's say made of silicon.
How do we know that, Massimo? I mean, we replace other parts of the body.
Technically, we cannot know it. It's not. I'm not saying that it's impossible. Now, as you know, there is this thought experiment again. One of these versions is due to Chalmers, where he says, well, but what if you replace neuron by neuron, bit by bit, with the equivalent made in, say, silicon, the functional equivalent made in silicon? Would you not, at some point, would you not have an entire brain that is made of silicon? And the answer to that is, well, I don't know. It's very possible that at some point you simply die. You just got enough silicon in your brain that you're dead. End the story. Or it's possible.
Your audio. Hold on a second.
Yep.
Okay, you're good. Go on. I think we had a little hiccup.
Right. So it's very possible that all will happen when you start replacing carbon-based neurons with their silicon equivalents, that at some point you're dead. That's it. I mean, we don't know.
I don't want to get too technical on this, but let me just ask you one thing in this specific area. What is different about your intuitions or understanding on this with respect to neurons as opposed with other parts of the body? In other words, there's nothing at all odd or counterintuitive about the idea that we can replace organs and other parts of the body with stuff made out of with replacements made out of a different substrate. What is it about the neural activity you think, at least intuitively to you, that seems to suggest that maybe it is more substrate dependent than the organs in our body and other parts of our bodies?
That's an excellent question, and the difference, I think, is, first of all, unlike any other part of the body, the brain is involved with precisely the kind of stuff that we think it's posing the problem to begin with, right? So the ability to generate qualitative experience of what it is like to do something. Everything else does not do that. All of the other parts of the body don't have that property. So the question is, that doesn't mean necessarily. I want to stress that I'm agnostic about this question. I don't positively make the claim. I'm not making the positive claim that it is impossible to get consciousness experience by using different materials. All I'm saying is I'm wary of people that say, of course it's possible, without further argument. We don't know. And I base that on the fact that lots of people seem to forget that neurons are not just a matter of electrical impulses. They also are a matter of very specific physical-chemical connections, right? And so if it were just a matter of electrical impulses, then I would say, well, it's more likely that you'd be able to replace them with something else, as long as that something else is sort of functionally equivalent, right? It carries electricity in a similar way. But that's not all the neurons do. Neurons are cells. They're living cells. They're made of stuff, and that stuff does something. They're not just a passive conduit for electric impulses. So you can replace other parts of the human body, let's say bones, for instance, with pieces of metal. But that's because bones are not particularly active. The major thing that bones do is just provide support, physical support for things. And so it's obvious why those are more replaceable. Other things are a little more complicated. I mean, artificial arts are more complicated. That you can make them of non-biological material, but they're more complicated because their functional structure, the structure that makes possible their function, is more complex, and it's more nuanced. But in the case of the brain, it is the most complex organ that we have by far.
Right.
And so again, I think it's an open question.
Yeah. And it sounds to me like, the obvious disanalogy for the layperson is that the principles of operation of a thing like a heart is essentially mechanical. And so it can be replaced by another mechanical device that does the same thing. But the principle of operation of the brain is neurochemical.
That's
And
right.
there you actually have to have the chemicals. Otherwise, it's not the same process, right? They're not functionally isomorphic. And they may be functionally isomorphic, but that does not mean that they can perform the same task. They are
Correct.
substrate dependent in that sense.
Correct. And as I said, we do have examples of substrate dependency in biology, in other areas of biology. Like one of my favorite examples, which I take straight from John Searle, is photosynthesis.
Right.
So, different organisms can do photosynthesis. Not only plants, but a number of different kinds of, algae, green algae, brown algae. A lot of bacteria can do, green bacteria, blue-green bacteria can do photosynthesis. And in fact, they can do it by using different substrates. It's not always the same molecule. Green plants use chlorophyll, which is why they're green to begin with. But there are other organisms that use different kinds of substrates. So clearly, photosynthesis is a biological process which is not tied to a particular type of substrate. But it's not that you can just replace anything with it, right? Whatever you replace it with has to have certain characteristics. In particular, it has to be a photoreceptor, for one thing. Otherwise, forget it. But it's not just that it has to be a photoreceptor. It has to be a molecule that is made in a particular way so that it not only captures the light, but it transduces the electrons, and so on and so forth. So I don't see why anybody would think that the brain is different. That doesn't mean, just like in the case of the photosynthesis, it doesn't imply that it has to be made exactly in the way in which the human brain is made. It's very possible that there is a range of materials and a range of putting it together. What I don't think is that you can make it out of just anything.
Right.
But if you're a strict functionalist in terms of philosophy of mind, you will have to agree. And in fact, as you know, this is in the literature, that you can get consciousness out of pieces of cardboard or out of billions of Chinese organized in the proper way. No, I don't think so. I think that's just crazy.
Yeah, and actually that was going to be my next topic, with some of the ideas underlying the strong AI thesis. And by way of a segue, maybe I'll just say one more thing about, because when we talk about the Turing test, we're really talking about moving to a performative account of thinking and understanding, as opposed to some other sort of account. And I think that maybe the last thing that I want to say about why this was attractive, and this historically is part of the reason why it was so attractive in the philosophy of mind, was the failure of a kind of physicalistic reductionism.
Yeah.
And so the big thing for a while, I'm thinking of J.J.C. Smart's sensation and brain processes and some of the other prominent first-line physicalists, was that we would be able to show that thoughts and other mental states are simply identical with physical states of the brain. Right. And we don't need to go into a whole discussion of reductionism, because we've done it before at some length. For whatever various reasons, that program failed. And so partly because of this idea that we've been talking about of multiple realizability. And so I think that maybe the reason why this whole way of thinking about it became attractive, it wasn't just because of a sort of a vague intuition of multiple realizability. When we actually tried to give physicalistic accounts, they seemed obviously incorrect. They seemed obviously like they couldn't be correct. And so the idea was to move maybe to a level of abstraction.
Right.
That would allow us to talk about these things without having to make the case for physical identifications that just we were not going to ever going to get. We're never going to get, in my view, some account that's going to tell me precisely which set of chemicals equals my belief that Florida is hot in the summer. Right?
Yeah, no, that's right.
Right. So do you think that also is part of the reason? That it was partly because of the failure of the attempt to give a physicalistic reduction?
I think you're completely right on that one. But then it seems to me that the sort of the pendulum kind of swung far to the other side of the field, so to speak. And now we get what, for all effective purposes, looks to me like a type of dualism, which is...
Explain that.
Well, so this idea that is now pretty popular that thinking or consciousness or both are essentially substrate independent, right? So all these idea that you can now upload, not now, but that you might be able to upload your mind to a computer, that sort of stuff. That, for all effective purposes, assumes that the mind is in fact not a physical thing at all. That can be instantiated. It's just pure information that it can be instantiated regardless of platform, right? To me, that is a kind of a dualism. Of course, it's not a Cartesian type of dualism.
I was going to say
Yeah, yeah,
it's almost more like an Aristotelian dualism in the
yeah.
sense of distinguishing form from substrate, right?
Correct. Correct.
Yeah.
Exactly. And again, my objection to that is not necessarily that I think there's anything impossible sort of in principle to these kind of things. It's hard to tell what's impossible in principle. I mean, very few things are impossible in principle.
Right,
if something violates the second principle of thermodynamics, that's impossible. But very few things fall into that category. So the question is, well, is it contingently possible? Is it feasible in a way? Do we have any idea of how that would actually work? And whenever I consider those kind of questions, then I go back to my background as a biologist, and I say, well, biology tells us that substrates are important. Plants don't think, regardless of actually some of our colleagues who have gone as far as writing essays about the feelings of plants. I don't think there is any shred of evidence or any particular reason to think that plants feel anything. And why is that? Why is it that any biologist would tell you that? Well, that's because they don't have a nervous system. And in fact, a lot of biologists would tell you that not everything even has a nervous system has it complex enough for that thing to feel something. There's a lot of discussion. For instance, this is going to be a little bit of an aside, but it might be important, interesting for our discussion. So there's been a lot of discussion recently about which animals are capable of feeling pain and which ones are not.
Right.
And so the suggestion, we don't. The short answer is we don't know. It's not true now. But there are a few things you can do about it. So one thing you can do is to look at, well, do animals, which animals have the kind of neural receptors that we associate with pain. And it turns out most of them do. Okay, plants don't, bacteria don't, but lots of animals, in fact, pretty much almost every animal has them. What makes things more complicated, however, you can't jump ahead and say, therefore even ants, for instance, feel pain. Well, not quite, because we know that biology does this funny thing. Evolution does this funny thing. It recycles structures and different components for different functions. So just because you have something that looks like a neural receptor for pain, that doesn't mean you actually are capable of feeling pain. We have plenty of examples in the history of evolution where things have been recycled to do different things. So how do we know? Well, a number of people have suggested recently that not only you want the animal to have the proper neural receptors, you also want that animal to display the proper kind of behavior. And so one interesting contrast is that between an ant and a crab. And if you cut off the leg of a crab, right, the crab does react precisely in the way you would expect an animal in pain to react. Okay, it tries to protect the injured part. It tries to sort of nurture the injured part. It reacts frantically, as soon as the thing has happened. Do the same thing to an ant. I'm not suggesting that people go out there and start chopping off ants just to do the experiment. But if you do the same thing to an ant, you don't get that sort of behavior. The ant just keeps walking. There's no protection. There's no nurturing. There's no nothing. So, does that prove anything? No. But it is consistent with the idea that the crab does feel pain, at least at some level, to some extent, and the ant probably doesn't. If that is true, that means that you have to have not only certain substrates in place, but also certain functional connections and certain, a number of other things have to be there for the organism to feel pain. And feeling pain, of course, is one of the fundamental types of qualia. It's one of the fundamental types of conscious experience that we know of. Right. So all of this, just to say that I think it's useful to remind ourselves that we're talking about biological organisms. And so when somebody says, well, there's no reason in principle why we cannot upload our consciousness to a computer, I think they're not taking the biology seriously. I don't think they have a good operational definition of what consciousness is. And I honestly don't think they have an idea what or how that would actually be done. Chalmers himself was kind of interesting. I wrote recently a commentary on a chapter that he published in a book, sort of a response in the same book, and his chapter was about mind uploading. But even at the end of that chapter, honestly, I must say, he said, well, if somebody came up to me and said, here is a way to upload your consciousness to a computer, but it's destructive, you're going to die, in the process, you probably wouldn't do it. And to me, that's the proof in the pudding. It's like, I'm sorry.
Right.
Then you're just making up stuff, and it's an interesting sort of general speculation. But if you're not willing to actually go and step to the through the transporter, if we're in a Star Trek like situation, then you don't really believe what you're saying.
Right. You're just having a late night college conversation.
Uh-huh.
Right.
Nothing wrong with that, but
so the two ideas that underlie the strong AI hypothesis, as we've been discussing it, are, and please, if you think I'm getting this wrong or something, correct me, are, on the one hand, are one, functionalism, and two, computationalism. Okay, right. So functionalism is the view that we've already been discussing, and that is that our account of what a thought is, or any mental state, is at a level of abstraction from the substratum. In other words, that we can give a account purely in terms of functions of thinking and believing and all the other mental states we want to talk about, without mentioning any physical substance. And the classic way that this is typically done is talked about is in terms of the relationship between a program and the machine in which the program is instantiated. So you can give a description of all the states of the program without mentioning any of the specific parts of the machine. And this is typically represented in the literature through what they call machine tables. And you can do this for something as simple as a Coke machine, or allegedly as complex as a human mind. So that's the idea of function.
By the way,
yeah, go ahead.
That's exactly why I characterized that view as a type of dualism, because there's this qualitative distinction basically between the software and the hardware. That's where the analogy comes from, the analogy with the computer.
That's right.
And really, the hardware is not made of anything. The hardware is information. It's implemented on a particular machine in a particular way, but it is in fact cross-platform.
You mean the software? The software,
sorry.
Yeah.
Yes.
Yeah.
But it is in fact cross-platform, at least to some extent. I mean, if you ever try to have a Mac program run on a Windows machine or vice versa, you'll see the limitations of cross-platforms anyway. But that's the basic idea, right? That software is a very, very different kind of thing.
Yeah.
Qualitatively speaking, from hardware.
And actually, it's even kind of worse than that, right? I mean, if you think about it, a program is really, or a description of a program is really an abstract object, right? Mm-hmm. And so there's something very odd about the idea that a thought would be an abstract object, right? Because isn't a thought an active process? But how can an abstract object be involved? In other words, the very idea of it of the idea that we can give an abstract account of thought and mind seems almost like a non-starter, right? Well, what do you mean that an abstract object thinks? What do you mean that
Right. But then I assume that brings us to your second point, which
so the second one was going to be, the second element in the AI program is computationalism, right? And so that the way in which the kind of program it is, the kind of processes that are going on are computational processes. That what it is to think is very similar to what a computer does when it runs a program. That is, it performs operations on the formal properties of symbols, on their syntactic properties, because that's how programs work. If people know programming, at the very bottom, ultimately, the programming languages are just series of zeros and ones, and the way that the machine distinguishes one command from another is simply from the configuration of these, from, in a sense, the shape of these strings of characters, right? And so the strong A program seems to me to be based on two assumptions. One is functionalism. That is, as a general matter, the account that we give of the mind is going to be pitched at this level of abstraction away from the substrate in terms of functions. And then that specifically the kind of functioning that the mind employs is like the way that a computer functions, that it operates. Would you say that that's roughly a fair?
Yes, I think that's a very good description. Now, the sort of one immediate problem when you bring in computation is that, surprisingly, there is not much of an agreement on what counts as a computation, right? So I mean, there is the Turing Church thesis about universal computability. There are people, again, Chalmers comes to mind, that go as far as saying that pretty much everything in the universe is a computer. A rock is a computer. Anything that can have more than one state is a computer. Now, yes, you can define computation in that sort of a broad fashion. But the problem is, it seems to me, that whenever you expand the definition of a concept that much, the concept is it risks losing meaning, or at least losing usefulness. Yes, maybe there is some interesting way, so generally speaking, in which a rock is a computer. But if that's what we're talking about, that's not helping me understanding human computation. Because we're not rocks, we're not even close to rocks.
Right.
So if you're telling me, well, you just human mind is a computer because in fact rocks are computers. Like, well, all right, that's right there. It's a non-starter. You haven't told me anything enlightening about what it is to think as a human being. You have to draw some more fine distinction there, because so this is in some sense is another example of. We were talking about a minute ago about this idea that abstracting things and generalizing things can be helpful. And yes, sometimes it is. But sometimes there's the drawback is that, but now we are forgetting that we're talking about a very specific type of phenomena, in this case, human intelligence, which happens to be instantiated in a particular type of physical system. And if you go to general, you may lose enough of the specifics then that you're not talking about the same thing anymore. Now it's not particularly helpful. I don't find computation. Computationalism comes out of an analogy again. And you just said a few minutes ago that analogical arguments are pretty weak. Mm-hmm. If you think, and in fact, before the invention of the digital computer, people thought of human beings as equivalent of mechanical machines, right? But that's because that's all they had available in terms of sort of analogy, and we don't think of people these days as the equivalent of of automata. So maybe next century somebody will come up with a different kind of analogy, and we will no longer think of brains as computers. Computers are wonderful machines, and we have learned a lot about certain aspects of what it means to be intelligent, I suppose, by thinking about computers. But it's an analogy, and like all analogies, you get to the point where it's you're stretching it to the point that it not only it's no longer useful, but it actually may become harmful because you think you understand something when in fact you probably don't.
So what are people taught? There's somebody on Scientia who periodically comments who seems to be stuck in a feedback loop on this particular idea, and I never understood what it meant, and maybe you could explain it. What do people mean when they're talking about computation in the biological context?
Good question. I mean, right?
Is there such a thing?
There is such a thing as computational biology, but that's a whole different issue.
Are there processes in biology, though, that can be properly called computational, not in this overly vague way that you've described, but in which we could actually view as computational in some meaningful sense?
Yes, but I think that those are the ones that are actually the least relevant to this discussion. So there are the kind of things that, for instance, that the peripheral nervous system does. So the automatic reactions, controlling the heartbeat and things like that, breathing, that sort of stuff. Those actually can be described usefully in a computational sense because they're fairly simple operations. They're predictable. It's a system that has ability to react to external circumstances, but within certain very specifiable parameters. And so there's a lot of that stuff that can usefully be described computationally. But then again, a lot of other biological processes can be described computationally. I mentioned photosynthesis not long ago. Now, we do have complete computational models of photosynthesis. And down to the quantum level. I mean, we understand and we can replicate in a computer the photosynthetic process down to the quantum level.
Yeah, but it's not going to produce sugar.
Correctly, exactly. So that's getting out of it is because simulation is sugar. Now, of course, whether that is a problem for human thinking or not, it depends on what you mean by human thinking, right? Because lots of people say, well, but it's not like the brain is producing something. It's not a thought is a physical process. Well, isn't it? Because I would say that, in fact, what the brain does is to produce electrical signals and chemical signals. That's what it does.
That's interesting, though. Depending on how you describe it, I could see it being more or less intuitive. So, for example, running is a physical process. Right. But don't tell me that if I lose my legs and I now have mechanical legs that I'm no longer running. Of course I'm running, right? So if you describe what's going on up here as thinking, that sounds a lot like running. Well, okay, well we could, but if you describe it as, what did you just say, producing certain chemicals, then of course, so
then it's not, right?
Right. So the level, the level at which you describe the phenomena sort of really radically changes the intuitions, right? But why would you say, what would be a reason for thinking it's less like running and more like?
I think it goes back. Yeah, that's a good question. That's a perfectly valid question, and I'm not sure that I have a particular answer to it, except to go back to what we said a few minutes ago, which is yes, but the brain is a different kind of organ.
Mechanical versus
mechanical versus electrical, chemical. So again, I hope it's clear that I'm not suggesting there's anything magic about the brain. It's not. I'm not a mystic kind of person. So I do think it's all about physical processes. But those physical processes are of a particular kind, and I think it behooves us to take them seriously as a particular type of physical process, and not confuse them with other physical processes. So mechanical processes is one thing, electrophysiological process, electrochemical process is another thing. That seems to be related. I mean, there is at least prima facie reason to think that it is the shift from mechanical to electrophysiological that makes consciousness possible. And, we wouldn't be able to, I don't think anybody has even suggested that we would be able to create a mechanical computer capable of consciousness.
Yeah, I didn't even mention consciousness just because I think that if we get too detailed, we're going to have too many problems that we have to chase down. So I'm just talking about thinking in the general sort of sense, and I'll let people worry about whether that implies more or less consciousness. Before we get just to the question of some of the arguments against strong AI, I just wanted to, about something you just said before that interests me. You said that there are certain biological processes that can be described in computational terms, right, without it being just a game of vagary. Right. But is it just that they can be described that way post hoc, or is there actually some plausible notion that the body is actually running an organic program?
That's a good question. No, I tend to reject the idea that the body is anything like a computer at any level. If you go all the way down to the basic molecular level, and people have been talking for a long time about genes as blueprints, as programs.
Yes, I've heard that kind of talk.
Yeah, and that metaphor is dead in the water.
Explain why, if you can, in a layman's term.
So this was a very popular metaphor for a long time, and then we got the Human Genome Project. Right, and so the Human Genome Project, if you go back to the early literature where people were trying to convince colleagues and in fact policymakers to fund the Human Genome Project, to get on board with the project, the thing that you would always hear is like, wow, we're going to have a human being on a CD. Because at the time they used CDs to store the image information, right? And it's like there was no cloud. And the thought was, well, once you have the sequence of DNA, you will know what makes a human being. You'll know. Therefore, we could go on and cure all sorts of diseases, cancer, and blah blah, et cetera, et cetera. None of that has happened. None of it. The Human Genome Project was a wonderful research project, scientific research project. We learned a lot. and we're now learning a lot more by expanding it to other species as well as to a variety of genomes within the human population. But one thing we don't have is a human being on a CD. And the reason we don't have a human being on a CD is because DNA is not a computer program. It's to make a human being or to make any living organism, it's a developmental process which relies, yes, on information for sure, but that information is not only, first of all, it's not coming only from the DNA, it's coming from all sorts of other, mushy material that we inherit from our parents. The cytoplasm in the egg, the mitochondria in the sperms. Things like that. You inherit that sort of stuff, and that sort of stuff is crucial. Without that, you don't get a human being, a functional human being. It's a developmental process. It's a developmental process that is mediated by all sorts of other chemicals. Some of which are inherited, some of which are not, but they are not DNA. They don't look like anything like a code of any sort. And of course, there is an environmental input, crucial environmental input.
Right.
Without environmental input, you don't get a functional organism. So, to me, that says that even at that level, where it was most promising, the metaphor of any aspect of a human being being a equivalent to a computer program has failed abysmally. It's just not that way. It doesn't work that way.
Right.
And so I don't see any reason why you would want to say, well, okay, it didn't work for DNA, but for the brain,
Right.
Which
If it didn't work at the simpler level, it's certainly not going to work at the more complex one, in which there are even more variables that impinge upon the specific shape that the thing takes. Right. I mean,
you would think,
right.
But, hey.
So that's really all very interesting, and so let's talk. We're getting to the latter part of our talk. Let's talk a little bit about one of the classic arguments against this, and I guess we've already, in a sense, voiced a lot of objection to this. A lot of it having to do with your belief that the substrate independence just simply isn't going to work, or is very unlikely to work. That when we get to an abstracted level of description, we're no longer really talking about the thing that we're talking about. We're talking about something else. But one of the arguments that has been most potent in this area focuses not on the functionalism, which is what most of our objections have been to, but on the computationalism, and that is, and I'm talking about, of course, John Searle's famous Chinese room thought experiment, which I'm sure when you post this on Scientia is going to cause everyone to have apoplexy, because there's people that are convinced that that's a terrible, terrible argument.
Chinese again. The Chinese room again.
Yeah, but I think it's a very strong argument, because it does somewhat get at what you were talking about. It's like, look, if by computation you mean anything like what computers do,
Right.
then it's immediately clear that if by computation you mean anything like what computers do, and if by thinking you mean anything like what people do, then it's obvious that a system simply running a computer program cannot be thinking, because, Searle's argument goes, when a computer performs operations upon symbols, it does so simply on their syntactic properties, meaning their shapes. It does not do so on the basis of their semantic properties, namely their meaning. In other words, the computer has no idea what the meanings of the symbols it operates are on. It simply has a list of rules that it follows. And Searle gives this very sort of intuitive, illustrative example to show this, that a computer wouldn't be thinking just by virtue of doing that, by imagining a human being doing what the computer does. So you give the human being a bunch of writing, none of which he knows what the symbols mean, and then you give him a bunch of rules. If you see these three lines, take 2 lines, draw a circle, and stick the paper out of the slot. And if you see those four, and so on and so forth. And so tried to show that you could, in a sense, have a person follow instructions in the same way a computer does, and it would be very obvious that the person had no understanding of what they were saying, and that therefore the machine has no idea what it's saying, and therefore this whole idea of computation as a model of what we do when we think is wrong-headed to start with. What's your view of the Searle thought experiment?
I am constantly puzzled by just how misunderstanding there has been about that thought experiment. There's a huge literature on the Chinese room, and of course Searle himself has gone several times in details answering a number of objections and so on and so forth. But I always thought that the experiment, the way you described it, is in fact very powerful. Not just because it appeals to my intuitions, because intuitions are not necessarily reliable.
You have to be
So
careful. They're unavoidable, but you have to be careful how you use them.
right.
Yeah.
And of course, my intuition, somebody can simply make the argument, well, my intuition doesn't go that way, etc. But to me, the thought experiment is simply a way, as you put it a minute ago, to make, to use an analogy, to use a sort of a fanciful situation, to make a very basic point, which is there's a distinction between syntax and semantics. And in order to get thinking in the way, and since we know that computers do syntax, but not semantics, we know that human beings do semantics as well as syntax, you need a way to bridge those two. That's not to say that this is impossible. This is not to say there's no argument in the Chinese room. The Chinese room is not an argument that says, oh, it is impossible to do it. It is simply a reminder that there is a missing step there, and that missing step is probably crucial. How do we get the meaning, the understanding, if you will, of what's going on, and not just the symbol shuffling? And to me, when people start sort of hand waving and say, well, if the symbol shuffling gets complex enough, you get meaning out of it. No, you don't. You don't. It's not. It's a different kind of thing that you're getting out of it. So I don't doubt there is a way to get it, because just like human beings again are biological processes.
We do it, right?
So we do it. So it's clearly possible to do it, and it doesn't require any miracles. But we do not know at the moment how this is done. We really don't have a good, at least as far as I can tell, we do not have a very good theory, a particularly good theory of meaning, especially not one that is rooted in the biological processes underlying how the human brain does it. I mean, as you know, we do have a number of theories of semantics, but they tend to be all expressed at a very abstract level, in philosophy of mind, and they're not empirically grounded. And I want to see a theory of meaning that is empirically grounded. At that point, I'll be able to say, aha, so this is how the human brain does it. Now let's see if and how we can actually replicate it in an artificial system. But until I see that, I'm going to be skeptical of any sort of general hand waving that says, no, the Chinese room is not a problem. And as you know, people who want to reject the Chinese room do get into these really weird situations where they have to admit that, the room is thinking. Or that, a population of people are organized in a certain way is thinking. It's like, no.
Yeah.
I find that not only counterintuitive, but just clearly a result of hand waving. You're not telling. What I see happening in those cases is a prior ideological commitment to the computational theory of mind, or to some kind of computational account of mind. And so, if you have that commitment, you have to bite the bullet.
Yeah.
Right? If you have that commitment and you're presented with something like the Chinese room, then you have to bite the bullet and say, yeah, the room is thinking.
Yeah.
But to me, it's easier to say, well, no, there's something wrong, or at least something incomplete, something missing in computational theory, and let's work on it.
Right. Let's just be quickly very clear about what the problem is, because when you say the syntax and semantics, people may not know exactly what that means. So let's just say, at a bare minimum, if I am thinking, doing what we call thinking, then if I think that my dog.
I hear your dog.
I know she'll stop in a second. My wife's at the door. At a minimum, to be able to say that I'm genuinely thinking, one has to be able to say something of the following. If, for example, I think that hamburgers are delicious, to genuinely think that, I at least have to know what the string hamburger means, right? I need to know that hamburgers refers to hamburgers, and I need to know what delicious means, right? The problem is that when a computer processes a sentence, it does so purely on the shapes of the letters and of the order in which they're strung, and so it's not only unclear; it's completely obscure what it would mean to say that what the computer is doing is thinking, because as you say, this was the way you put it, it has a syntax, but it has no semantics, meaning it's performing formal operations, but there's no credible sense in which you could say that it knows what these words mean. Now, the question is, well, there's two questions. A, what gives a string its meaning to begin with? And B, what would have to be involved to credibly say that something understands it or grasps it? And this is, of course, notoriously difficult. But it has led the people on the strong AI side to try to come up with additions to their computationalism by things like, well, if you attach a video camera to it such that every instance of the string hamburger is caused by an image of a hamburger, then we could say that the machine understands by that string the word hamburger. And Searle actually considers objections like that in the sequels to his article, his original article. And the problem with all these additions is that it keeps seeming like there's something missing. Yeah. Which is why people either then get spooky and start invoking all sorts of weird stuff, or they say that maybe the problem is that our conception of understanding does at some very deep level involve consciousness, right? Such that there has to be a certain conscious awareness of the relation between the string and the hamburger.
That's right.
Before I can credibly say that you know that the string means hamburger, but that then lands us in the consciousness problem, and nobody has the faintest idea.
Exactly.
But what I do think, though, is that the argument does show, in this sense I don't think it's just intuitional, the argument does, the thought experiment does show that whatever thinking is, it cannot be computation as we currently understand it as in computer science.
Yep. I agree, or at the very least, it cannot be only computation.
Right, I'm sorry, yes.
There may be computational aspects, very likely there are computational aspects, but it's not the whole story. There has to be something else. And unfortunately, at the moment, we have no clue to what that something else is.
Right.
Now, I'm not a Mysterian. As you know, that's another term that is bandied around in this kind of discussion. You know, people like Colin McGinn, for instance, say that, well, you know, we just have to understand that we may not have brains that are sophisticated enough to really get to the point of sort of understanding how they themselves work. Fine, it's possible. I mean, I don't think that there is any. I mean, we do know that there are certain things that the human brain cannot do. I mean, I cannot keep in my mind, you know, like 30 strings or numbers or things like that. So there's plenty of stuff. In fact, ironically, there's plenty of things that a computer can do already, and I can't do. Which is why I use computers to begin with. Otherwise, I wouldn't need them, right? So I don't have a problem with the idea that there are limitations to the human mind, and there may be certain things we're never going to be able to understand. But I don't find the Mysterian position particularly useful, because then it says, okay, so now what? Are we going to just give up and go home? No, I think there's still a reasonable expectation that somebody one of these days will figure it out. I mean, we've been in these kind of situations before, right? I mean, we've before Einstein or before Bohr or before Darwin, or before Newton, we had situations where nobody had a clue about certain major questions concerning how the world works, and then somebody figured it out, or at least started us down the right way. But I don't see at the moment anything that brings us that way. My hopes are not frankly pinned on philosophy of mind or anything like that. They're really pinned on neuro and developmental biology. But
that's what I was going to ask you last to close out. I was going to have each of us talk about what we think, where we think there are future prospects in this area. And so maybe, since that's what you were talking about, maybe you could tell us, where do you think and this is a guess, where do you think the promising work is going to be?
I am expecting progress in neurobiology, especially once that neuroimaging techniques get better and better. You know, right now they're very rough. They're very, very coarse. And despite what you see in newspapers and magazines, neurobiologists are not really capable of looking at a single brain in real time. What they do is, these really nice images that you see of the brain lining up this way and that way. They're really statistical composite of lots of different experiments. So. But I don't see any reason in principle why that cannot be improved, and will in fact improve probably in the next few years, because we're investing a significant amount of money in that kind of technology. So once you get to a much finer sort of real-time mapping of how the brain is working, and perhaps a better understanding also of the developmental biology of the brain. Because one of the things that we keep forgetting is this: most of these experiments are done on adults, but actually the most interesting things about the brain come out throughout development. We really need a lot more work done on the developmental biology of the brain. So I'm thinking that that line of research is going to give us a lot more information about just functionally how is it that the brain does the kinds of things it does. Now, whether that in and of itself is going to be sufficient to bridge the gap that we're talking about between sort of syntax and semantics, now, I don't think necessarily that that's going to be the case, but it may hint at ways in which you can do it. I think that a lot of the philosophy of mind that is going on right now, a lot of the speculation really that is going on right now, is not particularly insightful, simply because we just don't have enough facts on the ground to speculate reasonably about what's going on. We are in a very primitive stage from a point of view of sort of sheer basic biology, so that we make up very, very high level explanations or accounts of things, but we just don't have enough of the details.
Right.
So I'm hoping that over the next several years or decades, that's where we're going, and that's where the major positive advances are going to come.
Yeah.
Well, what do you think?
I probably agree with you in a sense, but I mean, I actually don't. I have zero hope that the neurobiology that you're talking about is going to help us in what traditionally are the questions in the philosophy of mind, because the things that we're really interested in the philosophy of mind are overwhelmingly folk psychological in nature, it seems to me. In the traditional philosophy, what are propositional attitudes? What are sensations? Right. And when we're talking about the object of these questions, we're talking about these things as understood via the categories and concepts of folk psychology. Yeah, and I think that there's a lot of basic category errors involved in a lot of these attempts to cross-explain. And so I think what's going to happen maybe is that the neurobiology will get so sophisticated that we'll come to understand that it's not the frame of reference from which to address a lot of the philosophy of mind questions. I suspect a lot of the philosophy of mind questions are really philosophy of language questions, and the traditional ones, the traditional philosophy of mind questions. And in other words, I don't think any neurobiology is ever going to find something that tells us what the belief that P is, right? It's just not going to work like that. I'm not even sure if it's going to tell us what beliefs are. Part of the problem, I think, has to do with the fact that I think we misunderstand the folk concepts. I actually am very dubious that there is such a thing as the mind, if you mean by the mind something like the brain, where it's a thing. We use the word mind 50 different ways. They all have a loose... I could talk about losing my mind. I can talk about being absent-minded. I could talk about being of a sound frame of mind. I could talk about being mindful, as you increasingly are in your life, and all that. And there are loose connections between these things, but the notion that there's a thing that we're going to find that is the mind strikes me as completely not.
I would agree. In fact, I tend
not going to happen.
To use that word. Yeah, I try not to use that word in that sense at all. I think of the mind as a verb, as minding.
That's good.
Minding is what the brain does when it is exposed to certain environmental conditions and proper functioning of the brain. So it's an activity. It's not a thing. But you're right. I think that term, using the terminology as if the mind were a thing, it really leads to very quickly to a lot of confusion, because then people are going to look for this thing somewhere, and they're not going to find it.
Yeah, and I even think that this extends to things like the free will issue and stuff like that. I think that we're basically, in this sense, I would do a very heavy a lot of Wittgensteinian work on the folk side. Yeah. And I would let the scientists do what they do, unmolested in a sense, and without this constant effort to sort of think that we're going to explain what we do in terms of what they are doing, right?
You're saying, if I understand you correctly, at some point in the future, philosophy of mind essentially being subsumed into two different directions. On the one hand, we're going to have essentially philosophy of language, or something along those lines, and on the other hand, we're going to have the neurobiology of it. I like that idea. Actually, I think I
hope at some point we're going to stop looking for beliefs inside people's heads. I mean, that's really what I'm hoping. Which is, if you think about it, how much of philosophy of mind of the last, since the 50s, has been the attempt to find the things in the head that are the ingredients of folk psychological explanations, right? I mean, that's in a sense what we've been trying to do. And I think that that's a project based on basic category errors. So I think the brain science is going to take us in directions that may create an entirely new set of questions, right? But I think that what we traditionally call the distinctive philosophy of mind questions are almost entirely really philosophy of language questions, and the extent to which we connect them to what's being done in the physical sciences of the brain, I think it involves category errors.
Well, we do agree, I think, because by now I know you pretty well, I think, in terms of sort of your philosophical underpinning. But I think we agree, however, that this is no support for something like an eliminativist view of things, right?
No.
So you're not saying, in other words, like the Churchlands, Paul and Patricia Churchland have been saying for decades now, that, well, once the neurobiology gets good enough, you're going to do away with the folk categorical, folk categories such as belief and sort of thing. Right. No, I agree.
No, I think that folk psychological explanation is here to stay. I think it will never go away. It's at the heart of moral discourse. It's at the heart of social political discourse. I think, people like Churchland's and before more sophisticated versions like B.F. Skinner, just misunderstand the nature of these, the social embeddedness of these forms of life, as I would call them. I don't think they're ever going to go away. What I hope stops is this very crude and ham-fisted notion that we're going to find all the pieces of them in our physical sciences, that somehow there's going to be, well, here's the belief that the bus is going to the mall, and here's the desire that goes to the mall, and now we know that the folk psychological explanation maps onto this physical explanation. I don't think that's ever going to happen. I think that folk psychological explanations are essentially forms of interpretation, and they're inherently linguistic. They're never going to cease to be linguistic, and they're not going to be found in the brain like you go digging for treasure. I mean, it's just not like that. It's just...
No, I agree, and I think actually the only difference, I guess, slight difference probably, is that I wouldn't use the word explanation as much as I would use the word sort of account or level of description or something like that.
I'm happy with that, yeah.
And we know that is the case in other sciences. I mean, for all these quip that you always hear from some physicists about, the table on which this computer is doesn't really exist because it's just a bunch of quarks. No. The table exists, my friend.
I hit you over the head with it.
I can bang on it, and I got a computer on it. I can tell you the table exists. Now, you're telling me that at a different level of description, that table is in fact made of what looks to me like a table is actually made of quarks. Fine, I got no problem with that.
Right.
But no, you're not going to be able to substitute quark level discourse in terms, instead of the table level discourse, because otherwise we're simply not going to be able to talk about tables anymore. I think that that idea of levels of descriptions and accounts is particularly useful and needs to be retained, because even philosophers have these physics envy, I suppose, or science envy more generally, of sort of, let's reduce it all the way down to the bottom level. Well, no, it's not. It's just not useful.
Or even the mistake of thinking that the accounts we give play the same role as explanations play in science.
Right.
They play all sorts of roles. Part of these accounts play what you would describe as a roughly explanatory or predictive role, but I often think that we are engaged a lot more in the folk psychological level in interpretation than we are in explanation.
I agree, and that's why
we're literally understanding each other is what we're doing, right?
Exactly. No, that's exactly right. That's why I'm beginning to characterize philosophy as being in the business of understanding or elucidating things, not of discovering things on the one hand. And another way of putting it is that I don't think philosophers deal with theories, although we use the term theories, and a theory of, right? But no, I think we have an account of. Yeah. And an account is a way to present something in language, in ordinary language, or in somewhat technical language, so that to increase our understanding of that thing. It's not at all the same thing as a scientific theory. It's not at all the same as a scientific explanation of things. And I'm perfectly happy with that, because I do think that even though there's a lot of back and forth between philosophy and science, I do think that there are distinct enough activities that it makes sense to say, well, no, this one is in the business of doing certain things. I mean, just like with science and mathematics, mathematics is not in the business of doing the same things that science does, even though the two very much interact with each other.
Yeah, look, I think that what happened was it turned out that some of the things philosophy was doing turned out to be scientific questions after all. But the mistake that people who are on your blog show remain nameless sometimes make is they think that there aren't any philosophical questions that aren't scientific questions or haven't turned into them. And I think that that's equally wrong. I would say philosophy is fundamentally about the logic and mechanics of interpretation, broadly understood. And that's why I always describe it as having a primarily critical function. And the sciences are about knowledge acquisition, right? And about understanding in the sense that we can actually predict, right? Explain and predict.
Right.
I don't think philosophy does that at all, right? I mean, so. All right. Well, we wound up agreeing again.
Damn.
It's all right. Well, I'll have to talk about religion sometime. Thank you so much.
It was a pleasure as usual.
And I look forward to our next time. Yes. All right. Take care, Massimo.
All right. Bye-bye.
Bye-bye.